So over here, we have 2x plus 2, 9x minus 5. Now we're going to get rid of x's on one side, we're going to get rid of numbers on the other side. So I'm going to subtract 2x. So if I get rid of x's on one side, I have to get rid of numbers on the other. Oops. I did that wrong. So I got rid of this. So I have to get rid of this. So what's going to happen is I have 7 equal to 7x, and then I'll divide both sides by 7, because what's in between the 7 and the x is a multiplication. Okay, and then done. Okay, so let's start doing, let's sort of expand on this now. So this is a good base of what we know. Let's try this problem. Let's try that problem. Right? Give it a shot. Let me know if anything interesting happens. Now, if you're doing this problem and something weird happened, you probably are doing it correctly. And the question is to identify, what does this mean? Okay, so let's do what we did over here. Let's distribute, right? I'm going to multiply this with this, and multiply this with that. And then for people who are copying, let me give you a little time to catch up and copy. Okay, now we're going to combine like terms. We're going to pretend like there's a wall here. And we're going to combine everything on the left and everything on the right separately. And what will happen is we'll get 2x plus 10 is equal to 2x minus 7. And then what we'll do is we'll subtract 2x from both sides. Okay. Now, you could subtract the 10 or subtract the 7 or just leave it. It doesn't really matter. I'm just going to leave it for right now. What will happen is that you'll get 0, which is basically Now, if you added 10 to both sides, I'm sorry, subtracted 10 from both sides, you get 0 equal to negative 17. If you added 7 to both sides, you would get 17 is equal to 0. The key thing here is you have something that's a false statement. Okay? You have a false statement, and you also have no variables. So let me let everyone copy that, and then we'll talk about what that means. Okay. All right, so let's think about what this means. When we're doing this, what we're doing is we're simplifying each line. We're saying the answer to this line is the same as the answer to this line. The answer to this line is the same as the answer to this line. The answer to this line is the same as answer to this line. So since x is equal to 1 here, then if I put 1 in here, this side will be equal to that side. Now we're using the same logic here. The answer to this is the same as the answer to that. The answer to this is the same as the answer to that. The answer to this is the same as the answer to this, which is a false statement, which means that there is no solution. Right? We came all the way down, we have no variables, and we've come down to the statement that just says 10 is equal to negative 7. Now, whether you had 0 is equal to 17 or negative 17 is equal to 0, it doesn't matter. What matters is that there's no variables and that this is not a true statement. So there's two ways of looking at it. You can see that there's no solution, meaning that it's impossible to find a number x, a value for x, where this side of the equation will be equal to that side of the equation. Okay. In the book, they call it a contradiction. Okay. So if you look at my old exams, you'll see no solution. Since you're using the XYZ homework, you'll just check on the box that says contradiction. It means that it's impossible to solve this problem. There is no solution to it. Okay, so let's try another one. So let's try doing something like this. All right, let's try doing that one. Excuse me. So let's give this a shot. So we get, oops, wrong color. So go ahead and distribute this. Okay. Now go ahead and combine like terms. Let's do that. Right. Now this looks weird. The left side is equal to the right side. If we didn't notice that, let's just say we kept on going and we subtracted 2x from both sides and subtracted 6 from both sides. And what will happen is we get something like this. So the same thing is happening here, almost. One thing that's similar to what we had over here is over here we have no variables. But over here, we have a true statement. This is saying 0 is equal to 0. That's true. When you're broke, you're broke. Okay. Now, so let's remember, the answer to this is the same as the answer to this. The answer to this is the same as the answer to this. Now, what this means when the left side is equal to the right side is that if I put in any number for x, the right side will always be equal to it, right? So let's think about it. Let's say we were to put in something like, let's say we were to put something down like x is equal to 3. I get 2 times 3 plus 6 is equal to 2 times 3 plus 6. Well, of course, this side is going to be equal to this side. The left side is the same as the right side. If I pick any other number, x is equal to 0.5. 2 times 0.5 plus 6 is equal to 2 times 0.5 plus 6. Of course, the left side is going to be equal to the right side. I'm writing the exact same thing. So the solution to this would be all real numbers. Okay. Now, the reason why I'm writing the real number like this is that at some point, I'm going to get tired of writing real numbers, and I'm just going to write it like this. And I just want you to get used to that. This is shorthand for real numbers. Okay, this double vertical line here. Okay. So the answer to this is all real numbers. The way they have it in the XYZ homework is they'll call it an identity. The identity means that the left side is equal to the right side. Okay. So when the variables cancel each other out, you have to look at whether the statement is true or not. If it's true, any number you plug in will work. Because even though I can't tell, this left side is going to be the same as the right side. If the variables all cancel each other out and have a false statement, it's impossible to find a number that makes this side equal to that side. So let's take a picture of this. Okay, so go ahead and copy. Okay. So I'm going to erase this right side. I'll leave this left side up for you. Okay. Now, on this right side, what we're going to deal with is fractions. So let's sort of look at how to deal with fractions. Okay, now we're going to end up with fractions a lot of times in this class, and most of the time we're going to be able to not have to deal with fractions, right? Fractions tend to be the thing that everyone messes up. So the best way to attack this problem is to get rid of the fractions. Now, the way you want to get rid of the fractions is multiply both sides by the lowest common denominator. Okay, so let me. So that's lowest common denominator. Now, for a lot of you, you're like, oh my God, I don't remember how to do lowest common denominator. What you're looking for is that if we look at these denominators, 2, 3, and 6, we're looking at what is the smallest number that divides into the smallest number that divides into all three numbers. I'm sorry. What number do all three numbers divide into? Okay. Now, there's a couple ways of attacking this problem. One way is to look at the common factors. So if I have something that looks like 6, 6 is equal to 2 times 3. Then I also have 2 here, and I have 3 here. Okay. I'm looking at the prime numbers that divide into this number. Now, over here, you say what's missing? 3. Over here, what's missing? A 2. And now we have an agreement that all these numbers will divide into 6. That's one way of attacking this problem. So let me, for example, give you this problem here. Okay. Tell me what the lowest common denominator of 14 and 6 are. Okay. And I know some of you are like, oh crap, I should have paid attention to what he was doing. I knew it was 6. Okay, so let's do it together. What prime numbers multiply into 14? 2 and 7. What numbers multiply into 6? And then you ask yourself, okay, what number is missing up here? What number is missing down here? So you get 6 times 7, which is 42. Let's try that again. Let's try 12. Let's try 18. Okay. Find the lowest common denominator. Now remember that we're looking at prime factors. So whether you start with by 6 times 2, you have to go all the way down till they're prime numbers, numbers that cannot be broken down any smaller. If you started with 4, as long as you go all the way down to the prime numbers, the numbers that can't be broken any further, you'll get the same factors. Right, so do the same with 18. Now, for some of you, you'll see the lowest common denominator, and you can just say, oh, it's 36. I can just see it. If you see it, then you don't have to do all this. But if you don't see it, then this is one way of attacking it. Okay, so what I'm missing over here is a 3, and what I'm missing over here is a 2. So now I have 4 times 9 is equal to 36. And let's try one more. Okay, let's try 14 and 15. Actually, 14 and 35. Okay, so 14 would be 2 and 7. 35 is 7 and 5. So over here, I'm missing a 5. And over here, I'm missing a 2. So then this should give me 10 times 7, which is 7. So we're going to have to be able to find the lowest common denominator. It looks like from the samples of the homework that I've seen that the numbers that they're looking at are fairly small. And talking to the owner of the company of XYZ, they purposely try to make it so these numbers don't get really giant. Most software, math homework software, they use really big numbers only because they weren't careful about it. And the one thing I do like this company is that he does try to keep these denominators fairly small and fairly intuitive. Okay. So once you find the lowest common denominator, what you're going to do is you're going to multiply both sides by the same number. Okay. Now we're allowed to do that. So for example, if I had something that looked like 2 plus 3 is equal to 5, well, that's true. Now, if I multiply both sides by the same number, let's say 6, I'm still going to get 30 is equal to 30. So as long as I do the same thing to the left side as I do to the right side, I will still have the left side and the right side equal to each other, even though this number is not the same as this number in here. Okay, so we're going to use this idea. Okay, as long as I do the same thing to the left side and to the right, to the left and right side, the equality still holds. So let's try that. We said my lowest common denominator is 6. So I'm going to multiply this side by 6, that side by 6. I know at this point you're not thinking that this makes the problem easier, but it will. Okay, and we're going to do this trick over and over and over again. Now, what I'm going to do now is I'm going to distribute the 6. Okay, this times that, this times that, this times this times that. And what will happen is I'll get 6 times okay. Now you're still probably thinking, this doesn't look easier. I feel like what I started with was easier. But we got to go one more step for it to get easier. Okay. So let's sort of look at this stuff. What we're doing over here is we're going to multiply each term by the lowest common denominator. And then over here, what we're going to do is we're going to divide lowest common denominator by the denominator. Okay. So I'm going to say 6 divided by 2 is 3. 6 divided by 3 is 2. And 6 divided by 6 is 1. And we're going to end up with 3x plus 1 plus 2 is equal to 6x minus 5, like that. And all of a sudden, we have no fractions. Okay, now go ahead and finish up that problem. So I'm going to subtract 6x here, subtract 2 here. And I get minus 3x is equal to minus 7. Okay, let me give everyone a chance to copy and digest. If you have a question, just yell it out. I'm not going to get mad at you. Okay, so for most of the people in the class, this should be a new thing. So if you're a little bit uncomfortable, this is the moment to ask. Now, I'm going to divide both sides by -3. And then I'm going to have x is equal to 7 divided by 3. Okay, so you're not allowed to have this double negative. A negative divided by a negative is a positive. Okay, I got a shy class today. So what we're going to do is we're going to do another one of these just to make sure you're comfortable. Okay, so
Doctor, can you actually go over the signs again?
Sure. On this line right here?
It says two negatives equal a positive and a negative.
Okay. All right. So when we have something like this, -4 divided by 2, a negative number divided by a positive number is a negative number. Okay. A negative number divided by a negative number is equal to a positive number. Okay, so if these two are the same sign, you get positive. If these two are opposite sign, you get a negative. Okay. Now, if you're to ask me, oh, today's my daughter's birthday, and if you're to ask me, so how old's your daughter? And I said, oh, she's -12 divided by -1. You'd think I'm a jerk, right? The normal way of saying this is, oh, she's just 12. So if you have this, right, I go like, oh, how much is that? Oh, -7 divided by -3. You'd say like, isn't this easier to understand 7/3? So whenever you have a negative over a negative, just turn it into a positive number. Okay. Is that better?
Yeah.
Okay.
On this problem, on
Mhm.
the one we just finished, I
Yeah.
did -3x on both sides and
Yeah.
then +5, but I got a different answer. I got 7 equals 3x.
Okay, let's try that.
And, okay. Hold on.
Okay. So we'll go, you did -3x.
Right.
Yep, and then +5.
Uh-huh.
Yeah, okay. So now you'll get a positive equal to a positive. 7 is equal to 3x. So for you, you don't have to divide, you already got a positive number.
Okay.
Okay? So either you'll get negative, negative, or you'll get positive, positive. But when we do this division, they'll turn out to be the same number.
Oh, okay.
Okay, better? Okay. All right, so let's try this again because you should be uncomfortable with what we did up here. Don't deal in fractions. We're going to be doing this all the time. It'll make your life easier. So even though this is something where you go, well, I like to subtract 1/3 from this and then subtract that from that. That's how they taught me when I took pre-algebra. I'm going to tell you that we're going to be doing this over and over again. So you might as well learn this now because in other things we do, we'll make things a lot easier. Okay, so let's try this one. Let's try 2/5x plus, go ahead, equals to 3/2x plus 1. Okay, now, I usually go directly from this line to this line. Only because it's a pain to write this an extra time. So I go from here to here. So the lowest common denominator here is going to be 10. Okay. You have 5, you have 2, and you have 10. So what I usually do is I go directly to 10 times this, 10 times this, 10 times that, and then 10 times that. Be careful because you have to multiply it with the, even if you have a whole number, you multiply with the whole number also. Okay, so give it a shot. See if you can do it. So what you want to do is divide this into here. So now you're doing a division. 10 divided by 5 is 2. 10 divided by 10 is 1. And then 10 divided by 2 is 5. So now you're doing this times this times that times that, and that times that. So you should have 4x plus 1. Okay. So now we're going to do minus 4x minus 4x minus 1 minus 1. And we should have, oops, I did that wrong. So I should have minus 9 is equal to 11x. And then divide both sides by 11. And then we're done.
Dr. Kwai, I subtracted negative 15x on both sides and did it opposite. Can you do it that way too?
Absolutely. Let's try it. Let's take a look at it.
Okay.
So what'll happen is you should get minus 11x and then positive 9. Let's try it.
Okay, that's what I got, but I was just confused.
No, you're okay. So let's try it. 15x minus 1 minus 1. So you'll get minus 11x is equal to 9, and then we'll divide both sides by negative 11. And then we're done.
Professor? Professor?
Yeah, go ahead. I hear you.
So just to better understand, this problem is similar to what we went over yesterday. The
Yeah.
only difference is that we would have to do LCD, which is multiplying to the highest denominator, seeing making sure that every denominator equals the same one.
Yes.
And
Yeah.
then we would divide, and then we would do the problem that basically we did yesterday by putting x on one side and the numbers on the other side, correct?
Perfect. You said it perfect.
Okay.
So all we're doing is we're extending this one more step.
Okay.
Before we didn't have fractions. Now we have one extra step that has fractions.
Okay, perfect. Thank you.
Okay, thank you. Okay, now it'd be nice if this was the last step, but we got another step to go. Okay, but we did the heavy lifting. So let's do the next step. Let me give everyone a chance to erase this because I want to start from the left side because these questions are a little bit longer to write. So maybe I'll just erase this very top part. I'll erase this first. I know. Now, for some of you, you're a little overwhelmed. Just know that when I teach Math 134, we start with fractions and we start with decimals. And we don't teach you decimals from scratch. We say, how do compute decimals using a calculator? So for those of you who are like, oh my God, this is too much for one day, take me 134 in the fall. It's open. I'm more than happy to have you. We're going to go really fast. So this class is really more about reminding people of something they've seen before. It's really hard if you've never seen this before or never conquered it. Okay, so let's try this problem.
But everything in this class is information that we have from 115, right?
Yeah, so basically 115 in this, about 2/3 of this class was from Math 115. So if you take in Math 115, you're probably in the right class. So 2/3 of it will be reviewed. So we'll do Math 115, but a little bit fast. And then the last third of the class is completely new. Now, the one nice thing is that in 115, we had a whole week of word problems, a week and a half. There's no word problems in this class. So it's Math 115 without the word problems.
Okay.
Okay. Yeah. So the first like 2 weeks, you'd be like, oh, I'm pretty good. And that last 1/3, you're like, couldn't you have spread out the new stuff a little bit? But that's what happens. That last 1/3 is going to be a little bit rough.
Professor,
Yeah, go ahead.
can I ask a question from the homework when you're done with this one, please?
Let's do it after class. So right after class, hang out and we'll knock them all out.
Okay.
Okay, thank you. And then just so you know, I am around before class. I'm just not in front of the camera. So if you go, hey, are you there? We got a question from homework. I'll walk in and do it for you. Okay. So just know that when the camera's on, I'm around. I just, just like you guys, I'm not going to stand in front of the camera waiting for someone to look at me. But if you yell, I'll hear you. Okay. So let's do this one. 2/3. Okay. So let's do, yeah, this one works. Okay. So, excuse me, this is kind of weird because now we have these structures. But just know that this problem works exactly the same way that the last problem worked. Okay. What you want to do is you want to multiply each term by the lowest common denominator. Okay. So first find the lowest common denominator. Okay, now in terms of terms are everything that are separated by a plus or minus. So this will get 1, this will get 1, and then that'll get 1. Okay. So go ahead and figure out what the lowest common denominator is. So if we think of 2, 4, 3, and we go, well, this is missing a 2 and a 2. This one's missing a 3. 4 times 3 is 12. So you're going to multiply each one of these by 12. Okay. Now, I want you to look at this piece right here, because this is the one that people usually have the most trouble with. Okay. If I give you something like we have over here, people are comfortable saying, oh, that's 6 times 4 is equal to 24. Now, notice that when you multiply these two numbers, it did not affect the third thing, the third factor. You can just multiply two things without it affecting the number next to it. So what you're doing over here is that you're going 12 divided by 2 is 6, and it does not impact that. Just like when I go 2 times 3 is equal to 6, it did not impact the thing that was next to it. So on this one, you're going to go 12 divided by 2 is 6, and now do the same here and then do the same there. So now what we're looking at is 6 times . So go ahead and distribute and then combine like terms. Okay. So you have 6x plus 12 . Minus 4x . equals minus 13. Okay, so go ahead and copy that, and then I'm going to give you another one cold to try, and then we'll take a little break. Give me 1 second.
So so you got negative 13 over 2. That's the same as 13 over negative 2, right?
Yeah, same thing.
Okay.
It'll eventually turn into, when you type it into the computer, it'll be something like that. But yeah, it's the same thing.
Okay.
Okay, so let me give you one more, and then we'll take a little break. I'm just going to erase this top one. So let's try. All right, try that one. Work your way down. Make this number bigger. Okay, now this here will cancel with that there. So now we have 4 is equal to 3. So let's remember what we did when we first started this lesson. We have no variables, and we have a false statement. So you can either call this a contradiction, or you can see there's no solution. Okay. Okay, let's take a 10-minute break. That's been an hour. So let's come back at 9:15. We're just about done with this section. We're going to do 1 or 2 problems with decimals, and then we're going to move on to 2.8. Okay? So hopefully we'll get through 3 sections today. We'll see. Okay. Let's take a 10-minute break. Okay? We'll meet back at 9:15. Okay, so let's get going again. We're going to do the same thing that we did here, except we're going to do decimals. Okay. Now, let's say I have something that looks like, well, let's just do this. 2 times 1 is equal to 2. I don't think anyone's going to disagree with me there. But if we start looking at decimals, 0.2 times 10 is equal to 2. 0.02 times 100 is equal to 2. And 0.002 times 1,000 is equal to 2. And about half of you are like, yeah, that's about right. And about the other half of you are like, I don't know. I don't remember how to multiply decimals. Thank God this class lets me use a calculator. Now, let me show you a little trick when it comes to decimals and multiplication. 10 means move this decimal one place. 2 zeros mean move this decimal 2 places. 3 decimals means move this decimal 3 places. So the number of zeros tells you how many places to move the decimal. So let's say I have something that looks like this. Give everyone a second to come back to their computers.
Is that 0.03?
Yeah, 0.03, yeah. Okay. Now, for each one of these, I want them to move 2 places. Right? You have to move them all the same number of places. So if I want these all to move 2 places, I have to multiply them with something that has 2 zeros. So what that will do is move the decimal 2 places, and I end up with something that's familiar to me. Then go ahead and finish up that problem. And then remember, after you ask your question, make sure to mute yourself, only because we start getting a lot of ambient noise. Okay, so I'm going to subtract 3 from both sides. I'm going to get 2x is equal to 9. X is equal to 9 divided by 2. Okay, so let me give you another one to try. Let me take a picture of this first. Now, usually when they give you decimals, they want you to end up with decimals. You want to finish with decimals. So then I will use my calculator and do 9 divided by 2 and write down 4.5 as your answer. Usually when they start with fractions, they have no problem with fractions as an answer. Okay. So let's try one more. All right, so go ahead and do that. Excuse me. Now, I want each one of these to move one place. So I'm going to multiply each one of these by 10. So I'm going to get 2, 3, that. Okay. And then I'm going to distribute. And then I'm going to combine like terms. So remember that the sign goes with the thing on the right. Sometimes if you circle like that, you sort of see it better. 2x plus 3x is 5x. And 6 plus 12 is 18. And when I subtract 18 from both sides, oops, I did something wrong. There we go. So when I subtract 18 from both sides, I get 5x is equal to negative 6. I'll divide both sides by 5. I think x should be equal to negative 1.2. Okay, so we just finished section 2.4, and we're going to move on to section 2.8. So let me give everyone a second to copy all that stuff. Then we're going to move on forward. Now, if anyone has questions on homework, stay after class, and I will bang out all the problems you have. And then for anyone who had trouble with technology, right after I finish all the homework questions that people struggled with, I will help you with your technology. So if you were not able to get on XYZ, if you were not able to get on the haiku, just stay after class and let's get you going. Okay. I can almost guarantee you. Okay, I'm gonna give you a quiz on Monday. Now, most likely what I'm gonna do is I'm gonna give you a practice quiz. So the practice quiz is not the same as the quiz. The practice quiz is gonna be about the same length as the quiz and around the same difficulty. So if you find yourself doing the practice quiz and going, oh my God, I couldn't finish, you need to study more. So the practice quiz is not there to go, oh, okay, he's gonna give me the same questions, different numbers. No, I just want to show you that you haven't studied enough. So if you take the practice quiz and you run out of time, just know you got a lot more studying to do. So the thing that you're racing with in this class is time, right? We're covering 2, 3, 4 sections a day, depending on how hard the sections are. And if you're not doing this every night, you're just going to fall behind. So if I tell you, get on the technology, you're going to run out of time, and then you just can't be bothered to say hey, I couldn't get on the technology, I'm a little shy, I don't like saying anything like that. Just so you know, you're not going to pass in this class. There's no way. It's already hard enough to pass this class when you're like, okay, get on the technology, I'm on it. Do homework every day, okay, I'm on it. On the weekend study, I'm on it. There are going to be people like that and still don't pass just because we're going 4 times as fast. Okay, so if you didn't get on technology, try it. If you didn't try it, stay after class. And then if you're one of those shy people who has to flunk before you'll like ask for help, take me in the fall, because we're going to go through, 15 sections this week, 16 sections this week. And if you ask for help 16 sections into this class, you're screwed because you can't make up that time. Okay. So if you are just kind of like, lackadaisical, because I know yesterday was not a fast day, it's just not going to work for you. Okay. So let's go
Professor?
section. Go ahead.
Will the practice quiz be on XYZ or is it?
Yeah, it'll be on
like-
XYZ. So what I want you to do is to experience what the quiz is like.
And it'll be timed and everything. So
It'll be timed in everything, and at
Okay.
the end, it'll give you your score and tell you what you did wrong.
Okay, but it won't
Okay.
count. It's just
Yeah, but it won't count.
practice.
All I want
Right.
it to do is have something there so you like mentally know, am I ready or not? Like, are your
Right.
expectations my expectations?
Got it.
Okay.
I had a question.
Sure.
When you said technology, you're talking about the two websites, the XYZ homework and the Power School Learning?
Exactly. Yeah. Those
Okay,
two.
sure.
Okay. So, look, most people are in this class because you've had some math teacher be really mean to you. Like, I get that. Like, what happens is you raise your hand, teacher goes, I want every question. You raise your hand, and then your teacher just swats you down and go, you should know that. I expect you to know that. Or why didn't you ask me earlier? Or I already went over that. Like, we have all these like terms to just shut you down. And I get that most people in the class, if I just went through every person and go like, all right, tell me your worst experience, someone said something horrible to you. So I get walking into this class, I have a whole bunch of students who have been really scarred by a math teacher. I get that. And I'm telling you right now, you're gonna have to get over that really fast. Every question you can't do, just ask me. And anytime I tell you to do something and you can't, you stay after class and I will stay with you and help you. Okay? All right, now, let's go, this is linear inequalities. Okay. Now, before we go into linear inequalities, we have to go into what's called interval notation. Okay. Okay, so let's make sure we understand interval notation. Now, if I say, if you were to ask me a question, my daughter is 4 years old. She's gonna have a birthday party. And you go like, hey, how old are the kids that can come to the birthday party? And I would say, well, they have to be older than 2, but less than 5. My daughter's turning 4. I don't want her to meet any older boys. It's just, no older boys. I don't trust older boys. Those kindergarten kids, untrustworthy. And I don't want to deal with diapers. So if your kid is in this interval, older than 2, I'm sorry, and you can be older than 2 or exactly 5. If you're one day older than 5, then no, you cannot be in there. You cannot come. Now, we can graph this. Like this. Where we can sort of say, well, all the numbers bigger than 2 and up to 5 and equal to 5. Now, if you see how this right here, this equal sign, is connected to this dot being shaded in. This means that if you're exactly 5 years old, you can come to the party. But if you're one day over, 5.1, 5.001, you can't come. Over here, this means is that you're exactly 2, you cannot come. You have to be 1 day or 1 second older than 2 years old. Okay, so this is we call this an interval because there's more than one age that can come to my party, right? You go, my daughter's 3, can she come? Yes. 4, can she come? Yes. 4.5, yes. 4.9, yes. 5.1, no. 2, no. You have to be older than 2 or equal to 5 or less, in between this range. So we call this right here graphing. Okay. And then we call this interval notation. Okay. When you have an equal, you fill in the dot and you have a bracket. If you don't have an equal, you don't fill in the dot and you have a parenthesis. Okay. So we call this right here closed. Closed means the same thing as equal. Closed means that we filled in that dot. We call this open. Open means the same as not equal, meaning that you cannot be 2. You have to be older than 2. Okay. So,
Excuse me, Professor.
go ahead.
So in this case, the sign right after 2, it should be like to the opposite side or not?
What? Say that again.
So yeah, the sign
yeah.
right after 2
Yeah.
should be like to the opposite side, meaning that it should be like older or not?
Yeah, older. Yes. So this is the smallest age, and this is the oldest age. So think of this as in between. You have to be in between 2 and 5. On the boundary, you go, can a 2-year go? No, a little bit older than 2. On the boundary, can a 5-year-old go? Yes, because we have the equal there. So think of this notation as in between 2 and 5.
Okay,
Okay.
thank you.
So go ahead and let's try this one. Right.
Professor.
Yeah, go ahead.
So the only kids that can come to the birthday party are kids ages 3, 4, and 5.
Well, but don't forget, we also add fractions. 2.1,
Oh, okay.
2.001, right? So you also have the fractions also, which is why we're shading the entire
Right.
line. Yeah.
Okay.
Okay. So go ahead and do this one. 3. Okay. So go ahead and write that in interval notation, and go ahead and write that, and go ahead and graph that. Okay. So when I graph it, I should have, so that's closed, and that's closed, and everything in between. Then over here, because both of them have an equal. Okay. Now, usually people are good with this. They go like, oh, okay, I got it. In between 3 and 7, yes. And if there's an equal, I shade it in. And there's no equal, I don't shade it in. And the answer is yes. Okay. Now, the harder part happens when we're doing, and let me put section 3.8 up here so you guys know. The harder part happens when we're working on greater than or less than. So if I say x is less than or equal to 2. If I were to graph it, I would graph it like that. Now, this is a new concept where we go, okay, what's the biggest number that I can think of? Infinity. Right? So my son used to have arguments with his friends, and they go like, you're stupid, and they're like, you're stupid plus stupid, and then you're like, you're stupid times 19. And then they started having this thing where you're stupid times 1,000, stupid times 1,000,000, and then they would come home, and my son would say, Dad, I need the biggest number you got. I got to win this conversation. I go infinity and go to school and go, you are stupid times infinity. And naturally his friend will go, well, you're stupid times infinity plus 1. Okay, now, the biggest number we can think of is infinity. Okay. The smallest number we can think of is negative infinity. Okay. Now, when we think about writing this in terms of interval notation, we say, well, the smallest thing I can think of is infinity. And then we go all the way up to 2. So this means any number in between negative infinity and 2. Now, the reason why this is the parentheses is that you can't touch God. Infinity is a number I can never quite get to. It's always a little bit too far to touch. So since you can't touch God, you always have parentheses next to infinity. Okay. So go ahead and try writing this to see if you can do it. All numbers bigger than 5. See if you can graph it and write it in interval notation. So when I was young, they say like Pac-Man was big. Pac-Man eats the bigger side. When I was really young, when I was in second grade, Peter Pan was really big. And they would say the crocodile eats the bigger number. Okay. So you're eating the bigger number, you're pointing at the smaller number. So this is x is smaller than 2. Over here, we're saying x is bigger than, we're eating the bigger number, is small, x is bigger than 2. bigger than 5. I don't know what you guys do now. Is it Bella? I guess Twilight isn't big anymore. Now, because this is doesn't have an equal sign, we're going to make this an open. And we're going to do it like that. Okay. Now, let's remember that even though it's not written there, the smallest number we can think of is negative infinity. The biggest number is infinity. So now we have 5 comma infinity. Because the parenthesis is always next to a infinity. So when you look at this equal sign, that's what determines what's next to the number. So over here, there's no equal sign. That's why you have a parentheses on next to the 5. Okay. All right, now. So let's see if you can do this. Do this one.
Professor,
Mm-hmm.
if it was infinity comma 5, would that be incorrect?
It'd be incorrect. You're asking a really great question. Always go small to big.
Oh, okay.
Okay, so you always have to do small number to big. That's the assumption.
Mhm.
Okay.
So once graph, just read the graph from left to right.
Yes, always left to right. Yes.
Okay.
Yes. Okay. And what you're going to find out in math is that whenever we describe something, we always describe something left to right. So for example, later we'll talk about this line. Is this line going up or is that line going down? It's got an arrow going in both directions. Whenever we describe something, we always describe it going left to right. So if I'm a car and I hit that line, I'm going up. You always describe it left to right. So this line is going up and this one is going down because it's always like we're reading a book whenever you describe an object, a shape, or math. Okay, so go ahead and see if you can write this in terms of the interval notation and graphing. Now, the way I like to think of it is you always point toward infinity. So I'm pointing toward the right, so the infinity is toward the right. In this case, we're pointing toward negative infinity, right? We're pointing toward the left. So I have negative infinity. Okay, so you always point toward infinity. In this case, we're pointing this way, so it's negative infinity. In this one, we're pointing this way, so we're pointing toward positive infinity. Oh, did I do that wrong? No, we're okay. This one here?
Yeah.
Oh, you're right. You're 100% right. Thank you.
And Professor, also the first one, the one
Yes.
with the 4 and 7,
Yep.
doesn't the part after 4 has to be shaded?
Yeah, it's shaded, but it's hard to see.
No,
Professor.
the part before, after
Oh, before-
4, like to the
On this side?
yes.
No. So because there's two of these, it means in between.
Oh, okay.
In between 4 and 7.
Okay.
Okay.
Thank you.
Yeah. And you'll find I make lots of mistakes. So if you see something, just tell me. You're
Professor.
probably right. Uh-huh.
So
Go ahead.
the sign right after 4, shouldn't it be like greater instead of lesser?
Right after over here?
Yeah.
Okay.
Shouldn't
Yes.
it be like greater, or it has to be like lesser?
Okay, so let me take a picture and I'll explain it to you. Okay. All right, you're asking a really good question. Okay. It's a really good question. It was actually the next point I was going to make. Whenever we're writing interval notation, we always want x to be on the left side. Most people, if I did a raise of hands, like what is this? Most people go, oh, that's x less than 4. Everything's smaller than 4. So then the question becomes this. Is 5 in this interval, or is 5 not in this interval? Now, what we're saying here is x is, now look which way we eat the big one, bigger. So really this is the same as that. So because x is on the right of this number, it screws up your intuition. This is saying x is bigger because that's where it's, the opening is bigger. X is bigger than 4. So it's really that. So the only time you ever have x to the right of a number is in this in between. So whenever you see this thing, these two will always be less than, and the way you'll read this is x is in between 4 and 7. Okay, so because x is to the right, that's why it messes up your intuition. Okay. Is that better or no?
Yes, thank you.
Okay. Now, there are a couple rules for inequalities. Okay. 1, x must be on left side. So if you have this, when you switch places, you also have to switch the inequality. So over here, it's saying X is bigger because the bigger side is facing X. When you flip them, the bigger side has to still point at X. So when you switch sides, you also flop the inequality. Okay, so when you switch sides, this has to switch. That's the first rule.
Professor, a quick question.
Sure.
So for the equation, the one that you have to the upper right, the x versus 5,
Yeah.
you put that one like to the right, but then the bottom one, I guess I'm a little confused. The x to the 8.
Yeah.
To the left. Why?
So you shade in the direction that it's pointing towards. See how this is pointing to the right?
Okay.
I'm going to shade in that direction.
Okay.
See how that's pointing to the left? I'm going to shade in that direction.
Okay, and then basically when you put it in the parentheses, the infinity, because on the other question you said the infinity, you would always go from the higher number to like the lowest.
Yeah.
So
No, lower number to the bigger.
Lower number to the biggest.
Yeah.
So it can always be the like 5 dash infinity in parentheses, correct?
Yes. Yes.
And then if it's the other way, then it would be the negative infinity.
Yes.
Dash 8.
Yeah.
Okay.
So infinity is always on the right. Negative infinity is always on the left. So you said it perfect.
Okay. Thank you.
Yeah.
So the question and the problem in the bottom, the 4 and the 7, if you switch those signs, would the graph stay the same?
You're not allowed to do that. So you're not allowed to have this. Okay, there's a couple things you're not allowed to have. You're not allowed to have this. So when we have this, we say X is bigger than 7. But over here, we're saying X is smaller than 4. So think of a number that's smaller than 4. 3. Can that number ever be bigger than 7? The answer is no. So these two things would contradict each other. That's why you can't have greater than signs here. They have to be less than. It has to be X is bigger than this number, but smaller than that number. Okay, that's why you think of it as in between. So you can't have this. The other thing you can't have is, let's say you both have 2 less than's, just like here. But if the bigger number is here, you have the same thing. X is bigger than 7, okay. But X also has to be smaller than 4. So that you can't be both at the same time. So you'll always only have this format like that. Okay. Now, there's one more rule. We're going to get there in a second. So this first rule is X has to be on the left side. And there's a good reason for that. Right now, you're doing math to please me. But at some point, you're going to be doing math for money. Okay? So if you go to your boss, you go, I need 20,000 2x4s because we're building a building. And I need all the 2x4s to be Is that bigger than 8 feet? Or is that smaller than 8 feet? Now, when I ask my students to raise their hand, I get 50% saying it's smaller and I get 50% saying it's bigger. Now, let's write this correctly. If I switch sides, I have to switch that sign. So I'm buying 20,000 2x4s that are supposed to be smaller than 8 feet. Now, if my boss, because I gave it to him in this way that's less intuitive, buys 2x4s that are too long, I just wasted the company way too much money. And for those of you who know, 2x4s are expensive. A smaller than 8 foot is much cheaper than a bigger than 8 foot. In fact, this is oftentimes considered scrap. Usually 8 foot's like the minimum size. So you could have bought this at a discount, but instead you're buying premium 2x4s that are all bigger than 8 feet. And then you bring them over, you times 20,000, that's a huge mistake. So the reason why you want to get in the habit of always putting X on the left side is that your boss might be a moron. Your boss may not know math. Your boss may have not taken this class in decades. And if you give it to him like this and he orders wrong, it's your fault because you could have written it in a more clear way if you didn't. Okay? So always write it so X is on the left side. So if you write it like this and your boss orders the wrong size, it's his fault. Because that's a huge mistake. That's a mistake that's, I don't know, $100,000. Okay, so these small little things are important. So X is always on the left side. Not because of me, it's because you don't want to make a mistake at work someday. Okay, now, let me clear the board of this. I'm going to leave these rules up here. Okay. There's one other rule. So let's think about this. Let's say I give you something big and difficult, and you get to the point where you go, 5x plus 2 is equal to 3x plus 10. Let's make it less than. Let's say I gave you this problem here, and I say solve. And you go, I don't remember how to do that. But I do remember how to do this problem. Maybe it's a lesson. We just learned how to do this problem. So go ahead and do that problem. Okay, so let's do the one we know. We would subtract this, Oops, what am I doing? Let me do that all over again. Let me go minus 3x. And I get 2x is equal to 8. And then I divide both sides by 2. And I get x is equal to 4. Okay. Now, what if I were to tell you half the time this problem and this problem are exactly the same? So in this case, this problem and this problem are exactly the same. So do the exact same thing you did here, but do it here. At the end, you'll get something like x is less than 4. Write that in interval notation. Okay? So do the exact same thing. This problem are exactly the same. Just carry that less than all the way down. Okay? And then write your answer in interval notation.
Professor?
Mm-hmm.
So the only difference with this new equation that we're doing is that once we put that, what is the correct name for that, like the Pac-Man sign?
Oh, the inequality.
Inequality. So the inequality sign, we just convert it to an equal sign. And then once we do the whole problem, then we would just convert it back to the inequality sign.
You know, I wouldn't convert it to equal. I would just leave it as an inequality all the way down.
Okay.
Okay. So let's do exactly what you're saying. Okay. I'm saying, yep, these are exactly the same problem. Now there are some people who are troubled where they're going, I remember there was something that was different. Like sometimes we do something different, and I can't remember what that is. Okay, we're gonna get there. Okay. So we get 2x is less than 4. Okay. And then we get 2x less than 4. We're going to divide both sides by 2. And we get...
I'm sorry, where did you get the 4 from?
Oh, I'm sorry, 8. I was a little too aggressive. We're going to get there. Thank you. And then we get x is less than 4. And if I was to write this in interval notation, I would get negative infinity to 4.
So after the x inequality to 4, we would still have to write it in parentheses. That would be
yes. You said.
And then we would be done?
You'd be done.
Okay. Thank you.
Yeah. Okay. Now, for some of you who are going, wasn't there something where I had to remember something? The answer is yes. See this last line over here? Everything will always be the same as what we did with equal, except when we get to this very last line. When we get to this very last line, if this is a positive number that we're dividing by, we do not flip the inequality. We keep the inequality the same. And for some of you who are listening to me, you're like, what the hell do you mean? Let me contrast that with something that's slightly different. All right, so let's do this problem. Okay. So now this problem is the same as that problem. The only difference is I put the 5x over here and the 3x over there. Right? That's the only difference. Now, what I'm going to do is I'm going to do the same thing I did last time. I'm going to subtract 5x from both sides. And then I'm going to subtract 2. And I get minus 2x is equal to 8. Okay. I'm sorry. Less than. Okay. I'm going to let everyone copy, and then I'm going to make my important point. I'm going to divide both sides by a negative number. See, over here, when I was dividing by a positive number, so I did not flip the sign. Because over here on this last line, I'm dividing by a negative number, you flip the inequality. So instead of a less than, it becomes a greater than. Now, let me write that in English. Okay. If you divide or multiply both sides by a negative number, flip the inequality. Let me give everyone a second to sort of digest it and then copy that.
Professor,
Go ahead.
can you give us an example of what you mean if you multiply both sides by a negative?
Yeah. So, for example, let me erase this slide. Not in this section, but later in life, you may get something that looks like this. Well, actually, let's not even do that. Okay. So what we've been doing up till now is getting rid of fractions, but let's just say we start out with some problem that looks like this. So really this is 1/4 x is equal to 5, and we want to get rid of this negative 1/4, and the typical way you do it is you multiply it by the reciprocal. So you would go -4/1, -4/1. And what happens is that this negative and that negative would cancel, become positive. These 4s would cancel, and I would just get 1x is equal to -20. Now, if this was an inequality, at this point here, because you're multiplying both sides by a negative number, it would flip like that. So you usually only get that situation when you have a negative fraction next to your x. It always happens on that very last line where you have x's on one side and numbers on the other. But in the way I've been teaching and the way these questions are set up, this isn't something that you're going to bump into in your homework. Solve here. Okay. Now, I'm going to show you a different way in which you can attack this problem. So let's say we have the exact same problem. Okay. And then I just want to remind you. Let me get orange. All right. This is positive. Don't flip. This is negative. That's That's why you flip. Okay. It's the number that you're dividing by over here that determines whether you flip the inequality or not.
So if you're dividing -16 by 4, you don't flip it because you're dividing by a positive.
Yeah, yeah.
Okay.
It's when you introduce it in the beginning over here. So on this very last line where you divide both sides by the same number, that's the place where you look for it. Okay. Okay, now you may have attacked this problem in a different way. You may have been one of those people where you go, I don't like negative numbers. I'm going to subtract 3x from this side over here. So then that means I have to subtract 10 from over there. And I don't like negative numbers. So this is good, right? I've got a positive number over there. And then I'm going to divide both sides by a positive number. So I still don't flip, which is fine. But then we got to go back to the first rule. X must be on the left side. Before you hand this over to your boss, you've got to do the flip for him because your boss might be a moron. I've had bosses that are morons. I got to give him the information the way that is easiest for him to understand. So when you flip this, you have to flip that. And you'll end up getting the exact same answer. So depending on your personality, there are some people who always solve this by bringing x to the left side just because that's what makes me happy. There are other people who always solve this by, I want my x to be positive. You'll get this situation, and then you'll do the flip because you change sides. Okay. Now, that's pretty much everything for this section. I want to do a few more harder questions just to make sure we're all on the same page. Okay. So let's do one with distributing a little bit longer. But just so you know, these are the only two rules that you have to know. Okay. Make sure x is on the left side. And right at the end, when you do that last division, check whether it's positive or negative. If it's negative, you got to flip it. If it's positive, you don't. Okay, so I'm going to just erase this part over here. Erase this part over here. Okay, so let's do this. -2. All right. So go ahead and try this one. Now, do you notice that over here, when we're distributing, it's a negative number? You do not flip. You only flip it when you are introducing that division by the same number or multiplication by the same number. It's when you add, that's when you do that thing, that's when you check whether you flip. So you can multiply negative numbers all you want that are in the original problem. You don't flip this, you keep it exactly the same. You just titrate this all the way down till you get x is greater than equal to something. And then when you do that last division, that's when you make the choice to flip or not. So go ahead and go for that.
Professor, quick question.
Mm-hmm.
So for the last problem that we just worked on, the one that says -8/2 inequality 2x over 2, it became a -4 inequality to an x. So if it's an x inequality to a -4, why do we have to flip that if the denominator 2 where you're dividing by isn't a negative?
You have to flip it because the x has to be on the left side.
Oh, okay.
Okay, so now we're not using this rule, we're using this rule.
Okay, thank you.
No problem. Okay, now you didn't have to do that. You could have also moved the 2x to that side and flip when you swap sides. Now you get okay. All right, now this is negative, so we're going to have to flip it. Okay, now be sure to simplify this. Never give me a fraction that's not simplified. So there's two ways of attacking this problem. You could say, what number divides into 22 and -6? The answer would be 2, and then you would divide. Now, for some of you, you're looking at that and go like, I have no clue what divides into both of those. So what you can do is look at the prime factors. You go 22 is equal to 2 times 11, and 6 is equal to 2 times 3. And then you'll see that that 2 cancels out. Either way you do it is fine with me. So one way is to do prime factors. The other way is just to, if you're good at multiplication, you can see what number divides into both of these. Okay, now after all of this work, you do not want to get this wrong because you didn't simplify your fraction. Okay, now go ahead and graph this and go ahead and write this in interval notation. Now, let's look at this. When I have to graph something that looks like this, so this is negative, if we look at this as, well, we're going to convert this to a mixed number, okay? Now, let me just sort of build on your intuition with fractions. If I give you this, most people are pretty comfortable that, oh, that's 6 divided by 2 is equal to 3. I'm kind of comfortable with that. So let's use that same kind of idea here. 11 is going to be equal to 11 divided by -3. Okay. Now, I'm not going to care about the sign. If I know a positive number divided by a negative number is going to be negative. So 3 goes into 11 3 times. That's my remainder. Now, you can sort of think of it like this. That this is equal to 3 remainder 2 divided by the same thing where we were dividing by. Okay. So what'll happen when you're doing the XYZ homework is that they'll ask you to graph it, and you've got to find -3 2/3 on the graph. Okay. Now where you'll find that is -3 2/3 in between -3 and -4. This closer one will be 1/3, and this further one will be 2/3. So you will graph it somewhere like that. Oh, sorry. Yeah, like that. And then you'll shade it in. So XYZ doesn't have a lot of fractions that you have to graph, but they do have some. So it's not a bad thing. It's actually good to be able to know where the hell is that number exactly on the number line. Okay. So the best way to do it is to convert it into a mixed number. Then you know where it's in between, and then you do the 2/3 part. Okay. And then interval notation is -11/3. Like that.
Professor, wouldn't it be a closed bracket?
Oh, yes, it is. It is a closed bracket. Thank you.
And if we graph it by simplifying 11 over -3, we don't write -3 2/3 and the interval notation.
It doesn't matter. Both of them should be okay.
Oh, okay.
Okay.
Thank you.
Yeah. Sorry about that. That was me, not an earthquake. Okay. Now let's do a similar kind of problem, but let's do it with fractions. Okay. Now the moral of the story is when you're distributing a negative number, that's not when you flip. You flip at this very end when we divide by a negative number. Okay. Okay. So let's try another one. So let's try fractions. Okay. So let's go x plus 1/3 is equal to 1/2 x minus 5/6. And then after you do that, you're going to graph it and then use interval notation.
So is this an inequality or an equal sign?
Yeah, I should put an inequality, shouldn't I? Since that's what we're studying. There we go. That's better. Okay, so let's multiply each term by lowest common denominator, which is 6. Then we're going to divide that, divide that, divide that. We get 6x plus 2 is greater than or equal to 3x minus 5. So we're going to subtract 3x, subtract 2, okay, now, because we divide by a positive number, we're not flipping, right? That's a positive, we're not flipping. So go ahead and graph that, and go ahead and write that in interval notation. So we know that 3 goes into 7 2 times, remainder 1. So if we think of pushing this into the denominator, we get x is greater than or equal to negative 2 1/3. So if I were to graph it, here's negative 2, here's negative 3. The 1/3 would be over here. I would say everything bigger. And then you would do, or you can do the mixed number. I just like to do improper fractions. Okay, now I'm not going to erase that. I'm going to leave that up there for you to copy. We're going to take a break for 10 minutes. But right before we do that, I just want to show you the tutoring. Okay. So if you haven't copied yet, don't worry. I'm going to leave that up for you. We're going to take a little bit of a 10-minute break again. But I just want to show you the tutoring. Okay. So I think sometime today, tomorrow, or Thursday, the tutoring lab supervisor is going to come in and explain this to you guys. But I want you guys to be able to access tutoring today. Okay. Now, the way it's set up is that we have two tutoring labs. Okay. One of them is called NetTutor. So I don't know how to do NetTutor. I think if you go off of Canvas, I think if you go into Canvas for this class, there's a link there that says NetTutor. You just click on that, and that is a professional company. It's free. We've already paid it for you, but you'll show them your question, and then they'll help you out. Talking to my students, they're very good. Okay, so you can do NetTutor. The nice thing about NetTutor, it is open all the time. So especially if you're a parent, a lot of times the only time you can really study is weekends, nights, and that's when the campus tutoring lab is closed. What they've done is hire a whole bunch of guys from India who have PhDs, and because India the wages are so low, they pay them $15 an hour, and they're up all night, and you can ask them in the middle of the night for help. And my students have used it, have said it's been great. Usually what they do is they hire people from India or they hire people from Montana. So if you're like if you have a master's in math in Montana, there's no places for you to work other than on a cattle drive. So they do online tutoring. Okay. Now, the other way of is doing it is we run our own tutoring lab, right? So this NetTutor that you can use any day, anytime is through Canvas. In terms of the math lab, you can click on here. It's set up so it works right after class. So right after class, they're open. So right after class, I'll answer any questions you have. But if you start working on homework and you get stuck, just click on this link. I emailed this to you in that bundle of stuff on the day before class, and it'll take you to the math lab. They have a little software where you show them the problem and they'll work it out. And they're basically students on campus. Okay. Now we found that students who use the math lab, they pass at a 10% better, I'm sorry, 20% better rate. So you're more likely to pass if you're using tutoring. The main thing I want you to do is not waste time. If you're stuck, I want you either ask me or call the tutoring lab. I don't want you sit staring at a question for hours, okay? Don't do that because that wastes your time. Okay, so let's put it back here. Let's come back at 10:50 and then we'll start the next section. We probably won't finish it, but we'll get a good piece of it done. Okay, thanks everyone. Okay, so let's get started again. Let's clear the decks. Now we're gonna start on this section, but we probably won't finish it, but we'll get a decent amount done. Okay. Now, let's see, right now we did 2.4 and 2.8. Okay. So your to-do list is section 2.4 and section 2.8. And the video, I have a few videos. Now, normally when I teach this in Math 134, what I do is I have the students watch core videos before I do the lecture. And then I do the lecture. And then the nice thing about that is that you watch the lecture in about 20 minutes or 15 minutes, the entire lecture that I normally spend about an hour or 10 minutes on. And the nice thing is that you can pause it, you can start it, you can stop it, and then you know what you know and don't know. So then when I go through it fairly quickly in the lecture, it's not as confusing. So the videos that I would recommend watching, because usually section 2.9, 2.10, and I think 3.1 are usually confusing. Let's let me make sure 3.1. Okay, 3.1. So I would recommend watching videos if you have the time for these 3 sections, because we're going to cover it tomorrow. If you only have time to watch one section, watch this one. That's probably the most important one. Okay. So for 3.1, it'll be something like graphing. It'll be something like graph 1/3 y plus x is equal to 7. Now, for some of you, you know you're terrible at that. Guess what? You should watch that video before I cover it. It's like 15, 20 minutes, but if you watch that video and then you do lecture, you'll be fine. Okay. This video right here for 2.10, it's things that look like this. Okay. Now, absolute values were not in Math 115, so for most people, that's new. Now, if you only have time to watch one video, I would watch 3.1. If you have time to watch 2 videos, I watch 2.10. Now, I'm not going to ask you this for every section, but I already know what sections you're going to struggle with, and I'm trying to save you time. If you watch these 2 videos before the lecture, you'll know your questions before you walk into lecture. And when I get into that part of that video you weren't sure of, you'll get clarity. Okay? So if these are things you struggle with, please watch these videos. 2.9 is what I'm going to start today. So if you're kind of confused with what I'm doing today, you'll know whether you should watch the video or not. But definitely, I would watch the 3.1 and the 2.10. Okay. Now, let's get going. So let me leave this here. And let's do section 2.9, which is compound inequalities. Okay. Now, I've never done this section virtually, and this section usually works a lot better with audience participation. So we'll give it a shot. Okay. Now, let me see. I identify as a male, and I am Japanese American. Okay, so I'm going to give you those statement of facts, right? I'm a guy, and I'm Japanese. Okay. Now the question is, is Dr. Kawai Japanese and a girl? Okay. Am I Japanese and a girl? In order for this statement to be true, both have to be true. I'm Japanese, but I identify as a guy. So the answer is no. Okay. So whenever you use the word and, both must be true. Okay, let's ask this question. Is Dr. Kawai Japanese or a girl? Right, so am I Japanese or a girl? So I'm Japanese, which means that I can ignore this part. Or means at least one has to be true. Either I am Japanese, or I'm a girl, or I'm both. So in this case, it's a yes. Because the idea here is at least one must be true. All right, so let's ask these questions. Is Dr. Kawai Japanese and a boy? Japanese and or a boy. Okay. A Japanese and a god. Japanese or a god. Okay. So go ahead and answer those questions. Okay. Am I both of these? Am I Japanese and a boy? I am both of these, so this is a yes. Okay. Now, or means at least one. Am I Japanese? Yeah. Am I a boy? Yeah. So at least one of these true. In fact, both of these are true, so this is a yes. Now, are both of these true? As much as I like to project it, I'm not a god. So both of these are not true, so this is a no. Now, because that's an or, is at least one of these true? Yes. So in order for an or to be a no, both things have to be false. Okay, so let's take a picture of this. Okay. Now, let's actually go to math. Now, just so you know, this concept of or and you'll probably come up in philosophy, and it'll also come up in your statistics class. So you'll see this other places. This is the right one? No, that's not right. Okay. Now, let's do something like this. actually solve.
I can learn to understand.
Now, the way to attack this problem, and then just so you know, this entire lecture is in that pre-lecture file in the haiku on the top left. So if any part of this you don't understand, or if you want to get ahead, just watch the lecture. Okay. Now, what you want to do is we want to graph both of these separately. Okay, now, this here, and look at this here. Okay. So we have x is greater than 18. And we have x is greater than 21. Okay. Now we're going to ask ourselves, okay, well, let me remind you guys, and means both. There are basically three intervals that we're going to look at. This interval, and that interval. So on this interval right here, this left one here, I'm going to ask you, are both of these shaded in? And the answer is no, they're not both shaded in. Are both of these shaded in? And the answer is no. Both of those are not shaded in, right? Just this interval here and this interval here. And then on this last one, we'll ask, are both of these shaded in? And the answer is yes, they're both shaded in. Now I'm going to take the endpoint of this one, right? Because we're going to look at this interval here. They're both shaded in. So then my answer turns out to be 21, comma, infinity. So go ahead and copy that, and then let me try to explain this problem to you intuitively.
Professor,
Go ahead.
aren't the second two number lines supposed to be solid circles?
Oh, I'm sorry. That should be solid circles. Yes. Thank you. Thank you. Thank you. Okay. Okay, yeah. The question is, what the heck kind of question is and and or thing? Let's say I was going to ask you, how old do you have to be to watch a rated R movie in a bar? Okay, well, in order to watch a rated R movie, I have to be older than 18. In order to be in a bar, I have to be older than 21. Now, it's very cumbersome to ask, when you ask someone, who can go and watch Pulp Fiction at this bar party that we're having? Well, you have to be over 18 and you have to be over 21. At a certain point, you just go like, why don't you just say you have to be over 21? Because if you're 19 and 20, you don't fulfill that constraint. So sometimes what happens is that you have multiple constraints, right? Multiple rules. And when you want to combine them in a way that's easier to understand, this is when you would use this sort of and or, okay? So both of these are not filled in, that's not filled in. Both of these are not filled in, that's not filled in. Both of these are not filled in. Both of these are filled in, so this is filled in. Okay? So let's try another one. Okay, so go ahead and do this. Do the same thing that I did. And then fill in the one that is both. Okay. Now, this is the very first thing that you have to be careful about. Always have the smaller number first. 8 is smaller than 10, so make sure this one's 8 and this one's 10. A lot of times, because this number comes first, people go, oh, 10 and then 8. Remember, this is a number line, so small number first. So if you made a mistake, that's probably the first mistake you made. Okay. Now, what we're going to do next is we're going to shade these in. We're going to say less than 10. And then we're going to say greater than 8. And then we're going to look at these three intervals separately, right? We're going to say, are both of these shaded in? No. Are both of these shaded in? Yes. So I'm going to take this endpoint. Are both of these shaded in? No. So then I'm going to take that endpoint. So then my answer is
Can you repeat the last part one more time?
sure. Okay.
Or how you got the 8 and 10?
Sure, let's erase this.
Okay. Thank you.
Okay. Now, what you're trying to do is you're just looking at these as sections like that. That section, the middle section, and then the right section. Okay. So if I'm only looking at this left section here, and I'm asking you, are both of these lines shaded in? Are both of them? And you're like, no, they're not both shaded in. So we don't shade this. Okay. Now we're only looking at this portion right here. And are we saying, are both of these shaded in? And the answer is, yeah, they're both shaded in. Now, I'm going to keep this endpoint because this part is empty, and I haven't decided over here. I don't know what my endpoint is here. I just know that this endpoint is going to get copied from here, and that's going to get copied. Now I'm going to decide on this last little piece. Are both of these lines shaded in? The answer is no, they're not both shaded in. So this won't be shaded in. So this needs an endpoint. I just grab the endpoint that I see over here. Is that better?
Yes.
Okay. Now, there's only 3 ways I can ask you this problem. I can ask you it with both of these lines going in the same direction. I can ask you with the lines crossing, and then the third way is to ask you where they're going apart but they never cross. Okay, so I'm going to do 3 of these problems with an and just know that those are the only 3 ways I can ask you it. So if you make, some people will make flashcards of sort of these core ideas. If you made one flashcard of each of these first 3 ands, that's the only way I can ask you the question. Okay, so now let's do one more. Let's go.
Professor, wouldn't the 5 and -3 halves be the other way around?
Yeah. Thank you. I was staring at that thinking, that's not right. Okay. Now, it doesn't matter that it's a fraction. You just have to know which one is smaller than the other. So this one is smaller than that one. So that's on the left side, that's on the right side. Okay. So we have bigger than 5. Oh, and then this is no equal sign. Okay. So let's look at these 3 intervals. Are both of these shaded in? And the answer is no. Are both of those shaded in? And the answer is no. And are both of those shaded in? And the answer is no. So nothing is shaded in. So the way we write nothing is this. So this is the symbol for undefined. Sometimes people call it no solution. Sometimes in some books they'll call it empty set. And they'll do it like this, but I think in this XYZ, I think they do that right there. Which means that, yeah, nothing works. There's no overlap at all. Okay. Now, let's play the same game with or. Okay? And means both. Okay. So let's do this where these are going in the same direction. What we go like that. Okay. So the setup is exactly the same. And this is x greater than 7, x greater than 10. Okay, so go ahead, copy that, and go ahead, shade this in. Shade in the greater than 7, shade in the greater than 10, and then we'll do the or together. Okay. So this is greater than 7. I'm sorry, greater than 7 is here. So my bad. And this is greater than 10. Now, or means at least one. Okay, now, is at least one of these shaded in? And the answer is no. Now over here, is at least one of these shaded in? Yeah, that one's shaded in. I only need one to be shaded in order for me to shade this in. And then over here, is at least one of these shaded in? And the answer is yeah, both of them are shaded in. But definitely one of them shaded in. So then our answer becomes, I'm sorry, 7 comma infinity. Okay, let's try another one. Okay, so go ahead and try this one. Oh, I checked XYZ. They don't use that. They use DNE if it doesn't exist. So this means does not exist. So if there's no overlap, use DNE. That's how they use it in your XYZ. By the way, do I have anyone that's colorblind? Because I know you can't. Colorblind students have a hard time seeing green and red. So if you're having a hard time seeing green and red, talk to me, and I'll replace it with oranges and purples. So I do have orange and purples whenever I do have a colorblind student. So if you are having a hard time seeing red and green, please let me know. Usually my colorblind students love orange. So we have 7 and then 10. And then one more thing. Some students have accommodations for extra time. If you do have an accommodation, I haven't received any notification from disability yet. So if you do have an accommodation, I respect all accommodations. So please, please, please go through SSD, have them notify me, and I will meet all of your accommodations. Okay. So I know some teachers are really kind of nasty about it. I am not at all. So if you have an accommodation, please, please let me know. Now, if you're in the process of getting it documented and you want to just tell me, email me privately and say, this is my situation, I can help work with you because I know the paperwork sometimes takes a little bit of time. So just notify me and I'll work with you. Okay. Now, when we look at this, we say, is at least one of these shaded in? And the answer is, yeah, at least one of those is shaded in. Is at least one of these shaded in? Yeah, at least one of those are shaded in. And is at least one of these shaded in? Yeah, one of those shaded in. So basically what we have here is the entire number line. So our answer becomes negative infinity to infinity.
Professor, would they both be parentheses, or would the right parentheses be a bracket because 10 is a solid?
Okay, you're asking a really smart question. The only time you're going to get a bracket from here is if 10 is in the answer. So if 7 is in the answer, you'll always get a paren because there's no equal here. If 10 is in the answer, you'll get that. Actually, that's not true. If 10 is in your answer, like this thing, your answer stopped over here, you would use a bracket. But because it goes past it, anytime you have something next to infinity, you use a parenthesis.
Oh.
So you only care about that bracket next to 10. You only care about that if the actual number 10 is in the answer.
Okay, I get it. Thank you.
Yeah. All right. Now, we are like 75% done with this section. So if you want to just start it, you could probably get most of this done. But I will rehash a little bit of what we did and finish this up. It's 11:30, so I'm going to set everyone free. And then whoever has questions, just bring it up to your camera, and I will just knock them out one after another. Okay? And then for those of you who have a technology issue, just wait until I clear those questions, and then I'll help you with your technology. Okay. Hang in there, everyone. Thank you.
I have a question real quick.
Sure.
So you'll be covering the rest of this lesson tomorrow, right?
Yeah.
Okay, thank you.
Okay.
Professor,
Mm-hmm.
We have homework due tomorrow, right?
Yes, yes. Whatever we covered on Wednesday. So I think it's just one section.
Okay, Professor?
Mm-hmm.
For the second line, I think you switched the signs. The x is greater than 10, right there.
Oh, I see. I see. Yeah, it should be like this, huh? That's what I drew. Yep. Thank you.
A question in regards to the homework.
Sure.
When we're doing the homework, we can like close the window and always come back, right? Will it save where we stayed at, or do I have?
Yeah. Every time you get it right, it just automatically saves it.
Oh, okay. Because I was worried.
Now look, if anything ever happens where you lose work, it happens. You know, it's a computer, right? Yeah. All you have to do is tell me, and I'll just give you the points back.
Okay.
I don't need proof, nothing. So if something happens where you walk away and it's gone, email me and go, this section, I don't need any proof. I'm just gonna say, you're right. Computers suck. I'll give you full credit.
Oh, okay. Thank you.
Yep. Mm-hmm. Yeah, I'm going to try to, usually what I tell you is more accurate than the XYZ. So after class, I think it says 2.10 is due. I'll try to remember to change the date to tomorrow. Yeah.
Professor?
Mm-hmm.
There was a question I had for the homework.
Sure, you want to show me?
Yeah. I don't have I'm on a computer though. Am I able to screen share?
You can't. You wanna text it to me? Take a picture of it.
Okay.
And just text it to my phone. And then
would it be better if I just put it in the Zoom chat or?
Sure, if you can do it. Sometimes there's fractions, so it's hard to see.
Yeah.
Let's see. I'm looking at the chat.
I'm unable to put like the inequality symbols there. I'll
That's
just send you a text then.
Okay.
So, Professor.
Just quick question, really quick. So the videos that you said about 2.10 and 3.1 will be through the haiku learning?
Yeah, let me show you exactly where they are. Okay.
Okay, perfect. Thank you.
And then today's lecture is also there too. So, all right, so let's pop it up. All right, so let me share a screen. Right here. Okay, so if we go into the haiku, oops. I don't know why that's not working. Let me stop that and try it again. And let me get in here and I'll screen share when it comes up. Okay, so let's go back. Okay, so when we go, if you go into the haiku to the very top left, there's this help videos by section. Now I went through, I already know what sections people are going to struggle on. Oh my gosh, Sheila, he's so cute. He did a good job today. Okay, let's see if this comes up. All right, so I'm going to click on there. For some reason, it's not letting me click on it, but I'm going to show you. I'm going to click on there, and let me show you what that file looks like. All right, let me show you. There we go. Okay. Now, once you go into that, file, you'll see 2.9, 2.10, 3.1. Now, do you see this one over here that say Kauai? All the ones that say Kauai are the ones I did. So I went and just started like, what's the most difficult section that everyone gets wrong? I did those first. Okay. So I would watch this graph line by plotting points. That's usually a topic that, especially you, because you're going to need that for trigonometry and for calculus over and over again. And usually in trig, they don't explain it. That's one of those topics, 3.1, where they go, I don't have time to explain it. Either you know it or you're just going to get those questions wrong. So I would watch the 3.1 first. It doesn't need any prior knowledge. So even though we haven't covered 210 and 2.9, this 3.1, you can just understand it. Okay. Now, if you, I would do that one first and then the 210 next.
Okay.
Okay. Now,
Thank you so much.
if you had trouble with today's, this compound inequalities is also something people forget. So usually when I do the lecture, people are okay with this, but the 2.9 and 2.10, by the time 4 weeks after now, when we go to the final, because these are the first two hard things that we learn, most people forget. That's why I have these, to remind you right before the final. But definitely this one you want to watch before tomorrow.
Okay, perfect. Thank you.
Okay, thank you.
Professor?
Did you text it to me?
No, it's somebody else.
Oh, okay.
Are we gonna have access to that haiku after this class is over?
No, but I'm always teaching this class, so we can do one or two things. You can either, if you need access to it, you just tell me, and I'll just give you access to my next class's access to it.
Okay.
The other thing too is that once this pandemic is over, sometimes students say, hey, you know what? Could you just put it on a USB? And I could just put it on a USB.
Okay.
Okay. All right. In fact, if you need it, I could put it on a DVD and mail it to you also. That's not a big deal either.
I appreciate it.
Okay. So I see this question. Let me put the question up here. So I have 2 plus 3x is greater than or equal to -7, or, all right. (4x plus 4 is greater than 12. Okay, so this was what I was going to go over tomorrow, but it's easy to do this right now. Now, what we want to do is we want to get to the point where we simplify these equalities. So I'm going to subtract 2 from both sides. And then I'm going to divide both sides by 3. And I'll get x is greater than equal to -3. That's my 1/2 of the problem. Now I'm going to do the same thing on this side. So I'm going to subtract 4 from both sides. And then divide both by 4. Okay, now this looks like something we did today. So once I've simplified both sides separately.
If he puts the answer, if he gets my answer, I'm going to be triggered.
And then we get 4 like this, right? So let's pop this in here. And we'll go, this is -3. This is 2. So then we're going to go from here. And then here. And then we're going to say at least 1. Is at least one of these shaded in? No. Is at least one of these shaded in? Yes. Is at least one of these shaded in? Yes. So then your answer should be -3 to infinity like that.
I put that into XYZ and it said it was wrong.
Did it say it was wrong? Which number was it?
That's number 4.
Okay, so let me look at it.
And I think there are other questions like that too. Like I think number 7 is wrong as well.
Yes, as well as number 9.
Okay,
number 9 is like that.
Wait. Let me so I'll make sure I don't put it on your test. 4
7,
7.
9,
Okay.
and that's as far as I've gone. I don't know if there's other ones.
All right. Whenever that happens, let me know, and I'll
Yeah,
make
I'll
sure
email
they're
you.
just not on your test. Yeah. Okay. I'll keep a list of that. Thank you very much.
So, Professor, what would we put as the right answer?
I don't know. What I'm going to do is I'm going to go and play with it myself, and then I'll email them to fix it. On the short term, if we have questions like that, I'm just going to boost your homework score, and it won't be an issue.
Okay.
All right. So
Sounds
you guys
good.
just tell me whenever you find it, because the big thing I don't want to do is put it on your test.
Right.
Right. Anything that has a bug in it. So I will go over it. I'll send them everything, and I will fix that.
I'll be sure to let you know if I encounter anything else.
Okay. Thank you.
Thank you.
Professor,
Yes.
From which homework is this question?
This question is from the last section we just did. It's in 2.9.
Oh.
Okay, so people are saying that question 4, 7, and 9 are incorrect. So I'm going to look at them after class, and then I'll send a text to everyone just to give them a heads up so you don't waste time.
Okay.
Okay.
So we have to complete 2.3 is due Wednesday.
Yep.
And 2.4, 2.8, and 2.9 is due Thursday, right?
Yes. Oh, wait. This is 2.9 will be due Friday, because we didn't finish it.
Okay. Thank you.
Professor?
Just to confirm.
Go ahead.
Just to confirm, you can do homework assignments in the future, right? For the future.
Absolutely. They're all open.
Okay. Thank you.
The only thing you want to do is, if you double check with me that we're going to cover that section.
Okay. Thank you.
Yeah.
Professor? I'm sorry. I had a misconnection while you were doing some lecturing. I had a question.
Sure.
Regarding the compounds inequalities. When it disconnected, you said that there was only 3 ways that you would be able to ask that question on the homework or on the test. What were they?
Okay. Good question. Okay. Now,
I lost connection.
Yeah, no, it happens. Okay. Now, what you can do is that on 2.9, if you watch the video for that section, it'll go over everything I did. So in case there's like, oh, could you do that again? It's in that video. You don't have to worry. Okay. Now, basically, I can either do something like this, and this is and or, meaning that I have 2 things that are going in the same direction. Okay. Or I have them going crossing each other. So what this looks like is see how they have this overlap over here?
Yeah.
So one of them is they're both going in the same direction.
Okay.
So then they have the overlap. Another one is that they cross each other. And then the third one is that one of them is going in one direction, the other one is going in the other direction, and then they don't cross over at all.
And therefore, that would be the one that's a no solution, correct?
For the and, that's no solution. For the or, it's something else. So
Okay.
for and or, so tomorrow I'll go through it. For and or, we're going to do 2 different things. For and or, we're going to do 2 different things, and then for and or, we're going to have 2 different things.
Okay.
Okay. And then if you watch that video, you'll walk through exactly what I did here, but slower with examples.
Okay. Thank you.
Yeah, it'll make that same point too.
Thank you. Have a good day.
You too.
Thanks.
Professor?
Uh-huh.
I have a question. I forgot if these are a different way to write this
Mhm.
problem.
Okay, I'm going to spotlight you. Go ahead.
Are these like the same? Like,
let's see.
Do you see that?
Oh, yeah. So like the top one, you'd multiply both sides by, I guess it's 5? Or is that 2? I can't tell.
No,
I
meant like, is this the different way to write it? Like, if you...
Are those 5s or those S's?
Those are... Which one?
I see... so I'm seeing the mirror image of your thing. So is that...
Okay. Let me try to find it.
I think what it is that she has like x plus 5 over 3, and she's asking if she can separate it to x over 3 plus 5 over 3.
Oh, okay. Show me again then. Let me see. Just show me what you had. I get what you're saying now.
Like this.
Oh, okay. The top one is correct, and the bottom one is, yeah, they're both correct. They're both fine.
They're both correct.
Yeah.
Thank
so
you
if
so
you want to
much.
convert it, you absolutely can do that.
Okay.
That's fine.
Thank you.
You're welcome. Anyone else have questions?
Professor?
Uh-huh.
How do you write the infinity symbol for the homework?
Usually what happens is you have this thing right here, and usually there's a little button right here. It doesn't look like a button, but there's a little like box over here. If you click on that box, it usually gives you the infinity that does not exist. It gives you the fractions. It allows you to press on there and give you the weird symbols.
Professor?
You can click O twice.
Also, yeah, a shortcut is that if you put double O, it will count as infinity.
Yeah, so depending on your computer, I've had some students that have trouble with that double O, and we've tried it and they've showed me. But yeah, I know that some students do OO, and for most students it works.
Thank you.
Mm-hmm. Anyone else? Is everyone else okay?
Professor, so when I log into the PowerSchool, the Haiku Learning website, there's a thing called studying for quiz number 1, I think, yeah?
Yeah.
When I click on it, it's not uploading any...
Yeah, there's nothing there yet. What happens is I'll go through my old exams, and I'll tell you this file and these questions. So until I don't fill it out until Friday after class.